Because I have seen people, even the half of the machine learning will get completed and they must not, they feel like they are having or facing challenges understanding what is the training, what is the test, and we applying data like that. So suppose if you guys remember the data set in which we have worked, loan data set, right? I'm just taking the example of that. We are having loan ID. Now we are having the applicant income. Then we were having the co-applicant income. Then there was loan amount. And the last thing was loan status, right? So consider, I'm just creating the dummy data set for you so that you guys can understand. Now, in this situation, we have to apply machine learning here. Okay. How come we are going to apply? You guys understand in the data set which we have read, there were approximately 614 rows, near about 13 columns. Okay. Understand first we have to judge the input columns and the output columns. Okay. Which means, guys, if you remember, I told you that there should be some input data set, which means a data set which we are going to feed inside the machine so that machine will understand and create the pattern of that data set. Later, I am going to predict or target the output on the basis of the data set, right? So that is nothing but your input data. Consider this loan ID, applicant income, co-applicant income, and loan amount. These all are the input features. We also call them as dimensions. If you guys remember what is a vector, I have already given you the explanation. Suppose we are having the entries present here like this. And if I ask you to create a vector out of this, your vector becomes somewhat like this. 1, 200, 100, 20, and 1. Which means it is going to pick up all the entries of row number 1 and convert that into the vector, making this as one vector. That will later we will see what is the eigenvalue and eigenvector. But just understand, this is nothing but one of the vectors, which is multi-dimensional vector. Okay. Now, understand one thing. Data set is your two-dimensional, right? If you guys remember the basics, the pandas and the numbers and started, we always talk about that. There is one dimension which we call that as vector. Two dimension we call matrix in the case of number. In the pandas, we call one dimension as the series and two dimension as the data. So this is a data set and we are trying to extract the vector. Understanding? Because since if I'm going to extract the matrix, it is, if you guys remember, I told you that in machine learning, we are not going to feed this data as it is, right? I told you that we have to convert this into number array, and then we are going to feed that number array in the machine learning. Because your model are highly inaccurate, or the model maybe we can say that if they are not going to accept your string type of highly allergic, you can say. You cannot give any string type of data set or any string type of column in your machine learning model. Okay. Understand now this is your load status completely looking like a string type of data. Now what if I want to give this data set into my machine learning model? I will try and encode this. Okay, remember this term. Because in the near future, we are going to deal with this term very soon. What is encoding? Encoding says that try to convert your string type of value into the numerical type of value based on some conditions. Okay, and here you can see we are having the string type of a data Y. We are trying to encode that. We will see how the encoding is going to happen based on the type of categorical feature. If you guys remember, we do have type of categorical feature. What are the two types, guys? If you guys remember, If I ask you what are the two different type of categorical features? Yes, anybody?
Nominal and ordinal.
Nominal and ordinal. Okay. So on the basis of that, we are going to perform the encoding. Based on the nominal, we are going to do some different encoding. Based on the ordinal, we are going to do some. Just to understand, we cannot directly feed the data set inside my machine learning model, which is string in nature. Okay. Coming back to the point where we were trying to understand the test and train, right? Let me just erase this. The vector I was just trying to show you. Okay. Now you are having the data set. I told you that these all are going to become input for your machine learning model. And this is going to become output of your machine learning model. Okay. In other words, you can also call that as target feature, which means this is something which we are going to achieve or which we try to achieve. Okay. Call that as target feature. This is something which we are going to achieve by applying machine learning model. Okay. Now, at this time, there is some need of training data set which we need to give our machine learning model. And another thing which we need to give is the test data set. Okay. Now, what is this train? What is this test? Understand, this is your input, this is your output. Let me denote that with X and Y. Consider this is your X. All the input feature are X. And one of your output feature is going to be Y. Understand? You can have multiple input features, but only one target feature which we are trying to achieve. Okay, there is no possibility that you are going to have multiple output or target values. Now, since we decided which one is X and which one is Y, what is the next thing? What is train and test? I told you that we are having 614 entries present here in the dataset and overall 14 some columns. Okay. In this 14 column, one we decided that it is going to be the target one. Let's make it the 12 or whatever. Let's keep it 13. Now we have to distribute this data set into the training part, the part which we are going to give to our ML model, from where it is going to learn and try to create the. Okay. Now, since suppose we are having the machine learning model, I am going to give train data set to my model, and my model will try to create patterns out of it. Now, the question arises what you are going to get and how you are going to get. What is the training data set? We defined here the training data set, yet no. So first we have to understand that what is the bifurcation of training and test, which means suppose the data set having 614 or 613 rows, how many rows I am going to give as the training data set and how many rows I am going to give as the test data set. What is test? Suppose you are giving your machine learning model some training data set. Your machine understands with some, your machine created some pattern. Your machine understood the data set. Okay, you can see it created pattern. Now you have to cross verify, right? Whatever pattern machine is creating, is it of any word or it is just random declaration of numbers, right? You have to understand that. So for that purpose, we take the help of test data set. Okay, to cross verify what my machine learned is correct or not. Okay, so there is one distribution to say the 70% of the data, let's say if you are having 614 entries, 70% of the 614 entries you are going to give as training data set. Remaining 30% you are going to give as the test data set when your data set is small in nature. Getting it? Small in nature means right now you can see we are having 614 entries, right? So when we are having the entries like this, the data set is very small in nature. I'm going to distribute my training data in 70-30 format. Now consider my data set is bit huge in nature, contains 1,000 of entries, right? So you can simply distribute them in 82 groups. Because since data set is huge in nature, you can understand one thing that even if I am going to give 80% distribution to the train, which means I am giving more data to my model to get trained, and we can test with the rest of the 20%. When we are having 1,000 entries or 10,000 entries, you can say that 80% of those 10,000 entries are going to be the test, 20% are going to be there for the training purpose. Simple. Okay. So understand based on the small data, we are going to do best distribution percentage, and based on the huge data set, we are going to do section distribution. Now scrolling this bit down, how the distribution happens. Understand X and Y already decided. Okay. We have already decided what is going to be the X, what is going to be the Y. Now consider 70% of this will go as the training. This is the 70% entry going for the training part. Understand that the training part gets distributed into two parts, which means your X train, which means training part contains input. Your Y train, training part contains output. Getting it? What we are doing, we are trying to tell our model that I am giving you this much training data set as input, and this is the output which is getting generated, right? If you guys remember the expression of y is equals to 2x, what was happening in that situation? We were just giving the data set, input and output. And it was creating that what to enter from the input so that I am going to achieve output. Such kind of things my machine is going to do it. Okay. Now this 30%, remaining 30% will go for the test part. Now test again gets distributed into two parts, guys. The input test and the output test. Okay. Abhi, your whole sole motive is to understand training. Test, I will let you know what is the purpose of this. Right now, just understand how training is getting distributed and how training is, we are bifurcating 70. Okay. क्या तक किसी को कुछ डाउट है? Are we good? Do you have any questions still here? Yes, no, maybe guys, anything. Okay. Since we are not having any sort of question, we'll move forward and understand now this X train, Y train, X test, Y test, what is the relevance of these things into the machine learning model? Which means if I try to feed the data in my ML model, how it is going to be. This is very, very important. So guys, this is a question for you. We are distributing 70-30 format, right? The data set is getting distributed into 70 or 30% format. So what do you guys think? Is it going to select the entries from the start? And what all 70% of entries from the start it is going to pick up? It is going to be the random picking of rows from the data set as 70%. What do you guys think?
It's going to be random.
It is going to be random. Since day one, we are talking about statistics, right? Everything is random here. Okay. We cannot be biased with the data set. We cannot select what needs to be there, what needs to get entered. Keep it random. And we are trying to keep it random. Once we apply the model, I'll tell you all of these things which we are discussing here, how we are going to distribute X train and X test, how this thing is going to be random in nature, everything. Okay. Coming back to the point, machine learning model works. This is very important. ML model works. Okay. Now, since I'm talking about how it works, which means we are talking about what to give so that we are going to receive the efficiency of the output. Okay. What we are going to give here inside the machine learning. Understand? This is your ML model. Okay. In your ML model, okay. So in your ML model, this is your machine learning model. So to train the model, what you're going to do, you're going to give two data. Okay. Which one? First is your X train, the training part. Second one is your Y train. Understand this, guys, very carefully, okay? This will give you some logic. Logic means what? Which means if you're going to enter X train and Y train to a machine learning model, it will understand the pattern present inside the data set and gives you the logic. Okay. Since we receive the logic out of it, now we have to test the logic, right? What all my machine understood is even correct or not, or it is complete garbage. So to test the logic, I am going to give X test. Okay. I am going to give X test only, nothing else. I'm going to give X test and I'll ask my logic to predict the output. So that is going to be a Y prediction. Now, if you guys remember, for the combination of X test, we already have Y test, right? For the combination of columns of X test input, we already have Y test as the output. Here, I am giving X test into the logic, okay, which machine learning model has created. It is giving me the prediction. So I am entering some data and I am asking my machine, based on what all you have understood, give me the output. And this is what the output it is giving to me, which is Y prediction. I understand. We are going to check. Already we have Y original or Y test. My machine learning predicted Y pred. What is the status or what is the difference between these two values? Is Y test matching with the Y prediction? If it is matching, which means my model is working perfectly fine. It is understanding very good. Once Y test is not matching with Y pred, I'm going to see there is something called as. And every one of you know that there is near about zero chances that your model is going to be 100% accurate, right? And if it is 100% accurate, still there is a problem. Okay. So we are going to deal with errors every next moment whenever we will apply any machine learning model to any data set. There is going to be some error every time. Correct? They're not going to, let's say, come without any sort of error and we'll say that accuracy is 100%, which means your Y test is matching with the every entry of Y prediction. That is not the case and that will never be. Okay, so there will be always some kind of error and these errors vary, which means the calculation of these errors varies for different types of models. Let's say if it is classification in nature, it is going to vary for the classification type of data. When it is, let's say, regression in nature, it is going to vary for regression type of data. Okay. So for classification, the error calculation is completely different. For regression, the error calculation is completely different. Now look into this and let me know. Because why I'm telling you all of these things first. What is the reason behind that? Because if I am not going to teach you, you will not understand what I am putting inside the model, what we are getting, why we are using y-test and why we are judging the difference between y-test and type-red. Just give it a glance. Giving you a moment to understand, okay? If you have any questions, you can ask, or else we'll move. Okay. So then we'll start one model today. We'll have a discussion over that model, okay, which means I'll try to explain you how the model works. If the time remains, we'll try to imply the model on the data set, or else we'll do that tomorrow. Okay. Just because these are the starting days of ML, I just want to go slow. Okay. So first model which we are going to talk about is the classification model. Okay. So guys, just for the quick revision, if you guys remember, we have three types of machine learning models, right? What are those three types? Type number one,
Classification.
supervised by
Supervised
Sorry, supervised
and reinforcement learning.
yes. Okay. How we are going to distinguish? This is a reinforcement to so that okay. Let's leave it.
supervised will have to label the data. And supervised will be the unlabeled.
Unlabeled data. Okay. And I'm going to talk about label, which means the pattern matching or pattern making. It's a bit easy here. And then I'm talking about unlabeled data, which means here the concept of what? Cluster comes into the picture. This is whole a lot topic within itself. When we talk about cluster, it is a separate topic. Okay, we'll talk about this. Now, when we are talking about supervised, first we are going to deal with the supervised ML. Okay, so in that supervised, we have two subdivisions: the classification and the regression. Which one is the approach in the exit poll? Okay. So exit poll is a voting. First of all, you guys are going to tell me. Exit poll is what kind of a data? Continuous or discrete? That is a big question. Dear chance. If you guys want to search it on Google, you can. गलत नहीं बोलना है. If you are picking the You want to check the probability for the exit poll, what kind of data it is. Please understand that, guys. Whenever you are having this survey thing, getting it? Whenever you will see some kind of a survey is happening, some counting is happening, understand that is always spontaneous. No, sorry, discrete in nature. Now you will ask me why. What I told you guys, spontaneous is something that you will see the entry getting changed every moment, right? कल टीवी को ओपन किया होगा, टीवी ओपन करके देखा होगा तो उनका चार सेक्शन दैट बीजेपी और समाजवादी पार्टी. आई एम जस्ट गिविंग रैंडम एग्जांपल बिकॉज़ आई हैवंट सीन. ओके, तो एक पार्टी के कितने वोट्स है, दूसरे पार्टी के कितने वोट्स है, तीसरे पार्टी के कितने वोट्स है. वो कांस्टेंट वैल्यू नहीं है गाइस. व्हाट इज डिस्क्रीट? डिस्क्रीट मींस व्हाट? वी नो कि इससे ज्यादा इससे कम नहीं आएगा. अगर मैं एक डाइस पे रोल करती हूँ 1 से 6 तक आउटकम है मेरे पास, तो आपको पता है कितनी सीट आनी चाहिए, और बीजेपी के पास कितनी सीट आएंगी, कांग्रेस के पास कितनी आई आखिरी में, और बाकी जितनी भी एक्स्ट्रा जो भी है, जैसे समाजवादी पार्टी हो गई, उनके पास कितनी सीट्स है, राइट? इट डिफाइन नंबर दैट वाज डिस्क्रीट इन नेचर. So understand this thing whenever the survey happens, okay, there is something called as discrete type of value comes into the picture, okay? Not continuous in nature. Because what discrete says? Discrete says that you are having some value which is not changing with time. By the end of the polling, by the end of the voting count, you must have seen that there was some desired number fixed for a particular party. The number of seat won, right? So understand this thing. The survey kind of a data always contains discrete type of a. Okay. Now, once it is discrete type of value, this is the question for you. Okay. Discrete is numerical or categorical. Everybody knows that it is numerical in nature, right? Numerical
Yes.
type of a data is for classification or regression. 300 to 320 is a discrete. Just a minute. In the chat box, you guys can see 300 to 320 is a discrete, guys. That was the case where the counting was happening. I'm talking about when the counting is done. Okay. Getting my point? Continuity means what? Continuity, I can say that if I'm going to pick up every village within some certain state, okay, and I'm going to capture the voting count of those villages. So, yes, now I got it. Okay, so if I'm going to do the voting count and I'll create the data of it, it will look like continuous in nature. Okay, this village got certain, gives certain kind of vote, second village gives certain kind of vote. Column will look continuous in nature. But since the counting is happening, by the end, we will get some discrete result, right? Since it is discrete, also random, discrete random variable, which means it is numerical in nature. Although it is supervised, guys, unsupervised completely work different. Okay, it is consider this is supervised in nature. Which one it is? Classification or regression? Of course, regression. Why? Because classification deal with your categorical type of feature or yes or no type of feature, right? There is some sort of order. Suppose if I give you the example of, let's say, is in Pune there is going to be rain tomorrow or not? Yes or no? Classification in nature. Are you guys going to join session tomorrow? Yes or no? Classification in nature. Such kind of a thing or such kind of a data, the target value always comes in the format of yes or no or in the format of some class. Let's say if I'm going to gather all 20 people height all together, okay, I'm declaring some categories. That let's say the height between 150 to 155 centimeter comes in the, let's say, short people area, 155 to 160 centimeter mid area, 165 to 160 to 165, I'm going to call them top. Okay. So you can see I'm creating classes, right? So your target column values will look like short, tall, and medium. Short, tall, and medium. These values are going to get repeated. So it's not necessary that every time you are going to get the values like yes or no. There is a possibility that values are going to come in the form of yes. Okay. Now you can see somebody has written voting result is classification. Voting result is classification when we know that actually how many parties are. Okay. Now, Mayanka, this is very important point we need to gather here. Classification means what? There should be some class, right? So as I was saying that BJP is one class, Congress is one class. Now we are having n numbers of class coming into the picture. Okay. So there should be some order. There should be group of at least 4 or 5. Then we can call them as classification. So if you want to consider on the basis of party name, then you can call that as classification. When you want to consider on the basis of voting count, that is going to be known. Am I making sense now? K nearest neighbor classification. This is KN. Okay. As I told you, it is classification type of a data. Then numbers are not going to come into the picture. What are going to come into the picture? The categories or category. Now I'm not going to read the slide for you. I'm directly going to explain that how the model works. Okay, just a moment. When we're talking about how the model works, can you see there is one graph? Okay, so here the application of graph, your every concept will come into the picture. So since day one, we learn Python, we learn stats, we learn PDA, visualization. All of them are going to get used here. Okay. K-nearest neighbor, here you can see, focus on the graph there. Okay. So there is some chemical component required to create the wine. Okay. I don't know how to pronounce this, but I'm just trying. This is rutine and this is myrisine. Okay. These two are the chemical components which is responsible in the coloring of the wine. Okay. If let's say you are having good butane and less of this, the wine is going to be red in nature. If you are having high isotyne and less butane, it is going to be white in nature. Okay. So we do have a classification of this wine colors along with the data set in this graph. Okay. All of your white wines are falling into this data point section. All of your red wine is falling into this data set section. You will most of the time see the classification graph is coming like this only. Okay. If there are two classes, consider white wine and red wine. Half of the class will go in some other direction. The rest of the class will go some other direction. It will create a group altogether. You can see it is highly visible. This is a one of the class. This is a one of the class. Let me show you one more. Introduction to machine learning. If you guys remember, this was the PPT which we have gone through on day one. Okay. You can see this is the classification. Okay. The classification problem is when output variable is a category, such as red, blue, disease, blue. Here you can see the red category is coming here, the green category is coming here. Now you will ask me why this one data point is coming into the red category. What is the purpose? So understand, it is deliberately just to show you that it is not going to be 100% accurate. There is a possibility one or two data points shall move from here, from there. Okay, that is okay. You just don't need to focus on this much accuracy. Okay? So if you are watching this, which means yes, there is a possibility that one of the data points will come here because we cannot show 100%. Coming back to the point, we were talking about k nearest neighbor, right? So close for that. Is it outlier? No, it's not outlier. It's just, let's say, as I have shown you, right? The chemical component required for judging that is it a red wine or white wine. There is a possibility that chemical component might be higher in this particular glass. Okay, let's say my reacetine is higher in this case where butane is bit less. So it is my data point is going bit in the direction of the white. It is red. There is a possibility that it can happen. Let's say some around one of us mix both of the white. Although the color is looking red, but the mixture of white is also. It is not outlier, it's just the chemical component allows us to shift the data point in some different class. Okay. Yeah, that is the point. You can say that misclassified data. Okay. It is misclassified data. You can say that trying to, but not following it to the class. Okay. Now, you can see this is how my problem question looks like. Now, what is, yes? Anyone? Somebody was trying to speak here? No. What is the major concern here? The major concern is we are having one glass of wine where the component is not there, which means we don't have any idea. And inside that white wine glass, inside that wine glass, do we have rutine available? Myristoyne available? We don't have idea. This is what we can say the new data point is coming into the picture. Okay. Now, once the new data point coming into the picture, what we have to do? We have to predict that is it going to be the red wine or is it going to be the white? Now you will ask me, we can see that it is going into the direction of the red wine, where majority of the red wine points are there. Can't we directly declare this as the red wine? Guys, you can see above, one of my data point is also going in the white wine section. Are we declaring that as the white wine? There is a possibility that the proportion of the chemical component must be 60-40, 70-20. There is a possibility. But you cannot change the color by that, right? Correct? Until unless it is 100% available, or in other sense, you guys can say misclassified. We cannot, by looking at it or by plotting with the data points, we cannot directly judge it. Let's say it is the red wine. Why to discuss so much about this? In such cases, which particular class this wine of glass is belonging to, we have to judge. Is it belonging to the red wine section or it is belonging to the white wine section? Now, try to associate this with the concept of the recommendation system, real life example. Whenever you, if you guys remember, whenever you watch a movie, right, your movie always contains some genre. Okay, genre means, let's say you like to watch suspense movies. You like to watch animated movies. Violence is also one genre. Okay, so what happens whenever you watch movie with a similar type of genre? Okay, nothing is visible. Just understand what all I have said. I am writing down. So consider you are watching the movie with some particular type of genre. Okay, you like to watch suspense movie again and again. You watch only suspense. So it is going to recommend you only suspense movies. Okay. Now here the wine of glass is coming. We have to judge in which category it is falling. Come tomorrow, you guys are opening the application. We have to judge where to lead you, in what direction, so that you can end up watching at least one series or one movie. Is how your recommendation system works. Getting it? Now, how the KNN is related to this? My K nearest neighbor classifier, how it is associated with this wine of a glass, and how we can apply the KNN on this situation. Kind of we'll see after 5 minutes. Okay, join in the board right now or in the screen. Okay. Chalo. So we were talking about, now we have seen what are the applications of this K nearest neighbor. Now we will see how this actually going to work. Okay. How shall I choose? Okay, this is way too far. Okay. Now, K nearest neighbor, how it actually works. Okay. By here looking into this section, some of the things we need to understand. Okay. Like what? K nearest neighbor. Within the name, if you understand every word, this is what the algorithm actually is. Okay. Leave the K as of now. Just let's talk about nearest neighbor. Okay. Nearest neighbor means what? I am going to judge the distance of my new data point with rest of the data points. Getting it? So this is the new data point coming into the picture. What I have to do is I'm going to find the distance of this new data point with rest of the data points available in my data set. You can see. Now understand one thing, although we are going to discuss that in near future on very detailed. As of now, finding the distance here are of two types. Okay, guys, we cannot just randomly find the distance. This minus this. You are dealing with the coordinates now, right? You are dealing with the graph. And whenever you are having the graph, you are having the coordinates in the graph. Since you are having the coordinates, we cannot easily find the distance of one coordinate to the another because both of the x and y is taking participation. Now, first type of finding the distance is called as Euclidean distance. Okay. Another is your Manhattan distance. Okay. As I told you, we are going to discuss about this in near future, very detailed concept. But let's talk about just a bit that how this Euclidean and Manhattan are different from one another. Do you guys know that whenever we create the graph, there is always a grid kind of a structure available in the graph? You guys have seen the real-time graph paper, right? You will always see the kind of boxes available in that graph. Okay. So consider we are having x-axis with some feature, and y-axis with some feature. Okay. Now, what I'm going to do is, when we are going, suppose we are having one coordinate available here, another coordinate available here. If I want to find the Euclidean distance, I am going to directly fetch the distance between these 2 points by subtracting the coordinates and squaring them. Which means, consider this is the coordinate. It's 1, 0, 1, 2. Sorry, 1, 2, 3, that's 3. This is 1, 2, 3, 4. So what is the coordinate here is? X-axis 1, y-axis 3. Here, x-axis 4, y-axis 2. Okay. Now, if you want to find the distance between these 2 points, I'm going to take the help of Euclidean distance. It says x2 minus x1 square, y2 minus y1 to the whole square. sum them up, root over them up. Okay, this is what Euclidean distance looks like. Basic. If you guys remember, this is something which we have already learned in the geometry, how to find the distance between two coordinates. The same distance we are going to find here with the help of Euclidean, which is by default. Here in the case of k nearest neighbor, we are going to find the Euclidean distance considered to be the accurate one. And this is the formula of that. Now the question is, do we need to apply the formula on our own? No, it is already there, built in your algorithm by default. So if you are going to apply k nearest neighbor algorithm in your data set, it is going to pick up Euclidean distance by default. Okay. Now let's talk about Manhattan distance. The advantage, disadvantage, we'll discuss about this thing later. Okay. As of now, just we are understanding what is this Euclidean distance, what is this Manhattan. Euclidean you have already seen. Or is Manhattan? Manhattan distance says that I am going to find the distance between this, and this. I am going to follow the grid. Now you can see that the grid can be followed from here as well. Both are going to give you the same answer. If you guys have the idea of graph theory, maybe somebody of the tech background or let's CSE background, you must have heard of the concept of graph theory. The shortest path from one point to the another, right? In the graph. This is the same thing. We cannot directly go like diagonally, which Euclidean distance was doing. Manhattan distance says that I am going to go and move forward with the help of. Okay, so it is going to calculate the distance 1 grid, 2 grid, 3 grid, 4 grid, somewhat like. We'll give you the answer as 4 grid. Simple. Getting it? Block by block. You can see that. So here in the case of our k nearest neighbor, it is by default Euclidean. Okay. If you want to make it Manhattan, you have to write the codes. But if you want to simply keep it as Euclidean, you can directly write it. Sure. Moving forward, we have to find the distance of this new data point with the rest of the data points. Okay. Okay. We have to find the distance from this new data point with the rest of the data points. Once we find the distance, what is the next job? We found the distance. Now, what is the next job? To identify the nearest one. Okay. It's very simple. You are finding the distance. Okay. Now, you have to judge which all data points are coming near to the new value. You can see this is the unknown glass coming into the picture. I want to judge what all rest of the glasses are near to this glass. Okay. How I can do that? The basis of distance. From my glass, let's say the new data point, which is the another data point where the distance is very small, I'm going to pick them up. Simple. Let's say consider the distance from this to this glass is 1 and distance from this to this glass is 0.5 and to this glass is 2. Which one is the nearest one? This glass, right? Likewise, I am going to find my nearest glasses. Now you will ask me the question, how many nearest glasses, right? If I'm going to pick up 0.5, it is near. If I'm going to pick up 1, it is also near. If I'm going to pick up 2, it's going to be near as well. The question arises here is, how many near glasses to find? That is nothing but the value of k. What was the name of the algorithm, guys? K nearest neighbor. Nearest neighbor, I am going to find the distance of the new data point from rest of the data points. I am going to identify how many it should be there with the help of value of k. Suppose the value of k we will see. We do have a calculation, separate calculation for calculating the value of k. Okay. We will, let's say, assume as of now, the value of k is 2. So first of all, you will find the distance, Euclidean distance of new data point and rest of the data points. Based on the value of k, I am going to pick my nearest 5 data points. Nearest. Okay. Now, the nearest 5 data points are going to come into the picture. Then we will do devoting. Okay. The majority of the data points. Let's say if I'm having out of 5, if I'm having 3 data points as red and 2 data points as white, we will go with the majority. And I'm going to say that my nearest neighbor, or let's say my unknown data point, is the red wine, because my majority is red wine. Suppose if 3 of them is white and 2 of them is red, I'm going to say that my new data point is the white one. Basically, we are finding the nearest neighbor on the basis of the majority. What are the nature of the data points? I'm going to assign the same nature to my new data point. Getting it? Getting the point? Just give me a second, guys. Look into the screen. Yes. So do we have any sort of questions here? Are we fine till here? Will there ever be time? Very good question. If we can choose, this is something I was expecting. Top-notch question this is. Can we take a break? No, not as of now, because within 20 minutes, I'm going to end the session, okay? I don't want to overburden you. As I can see, it is getting overburdened. So the question arises, what if it is a tie? We deliberately never choose the value of k to be even. Okay? I'll tell you what is the procedure for selecting the value of k. But before that, always understand one thing, guys. Even if given a chance, you are never going to choose the value to be even. Okay? Let's say the value of k comes out to be 16. Okay? I'm going to go with 16 because there are high chances I'm going to get 8 glasses of white wine and 8 glasses of red wine. Then what data point I'm going to assign to my new glass? It will become a tie. And we don't have a concept of tiebreaker here. We cannot do super overs and we cannot do confidence voting, anything here, right? So in such a case, always try to choose the value of k as odd. And that is what defined is. We have to keep every time the value of k as odd. That is what the algorithm says. Okay, so let me show you one more thing. How to identify the value of k. This is the last topic for today, okay? Because the discussion of how it actually works and how it is expensive, we'll do that tomorrow. Because it is, I can see it is too much for one day, okay? Now we're going to find the value of k. That is the question. We cannot assume it. You can see there are so many options, okay, for choosing the value of k. I'm leaving it for you guys. Because I'm going to give you the PPT, pick up the PPT and read it. Okay. The precise one is this. Now, I want your bit of participation. Okay. This is the last question for today, maybe. In general practice, choosing the value of k is equals to square root of n, where n stands for number of samples in your training data set. Which means what, guys? Root over what? Root over x train, root over y train, root over x test, root over y test. What should we do? Very basic. WB, whenever you want to find the value of k, x train. And do we understand one thing, that the count of x train and the count of y train, they both are equal? Training data set, correct. The count of your x train and the count of your y train, both are going to be equal. Either of them you can choose. Okay, which means the focus should be on training data. Okay, so suppose 614 entries we were having in the loan data set, right? If you guys remember. So in that 614 entry, if I'm going to distribute them with the 70-30 format, whatever count coming as the 70%, I'm going to make that root over. Chalo, let's find 614, 70% of 614. Cross 614 cross 0.7. Let's find it. I don't have the data open. 614 multiply 0.7. 429.8. Okay, or you can consider that as 430. Okay, so if I'm going to make the root over of this, root over 430, what is going to be the value of K then? K equals to count of numbers of entry present in the training data set. That is 430 entries for us. Root over 430 entry. Let's pick that in the calculator. I'm going to do the root over 20.731. Value of K is coming here as even. Do we want even value? No. So 0.73 is here. Make this as the odd one. Make it as the 21. So we are going to select the value of K here as 21. Simple. Then what will happen? I'm going to find the distance of the new data point with rest of the data points. The value of K is equal to 21. I'm going to pick up 21 nearest neighbors. I'm going to do the voting. Whichever the majority voting is going to be there, I'm going to assign my new data point back to us. Make sense? Getting the point, guys?